All right, everybody. We're on 4.2, which is about area. I was hesitant about teaching this, and I thought about just doing a quick little summary of it, but I do think it's important. It's a bit algebra heavy, but I will ask you on your next assignment to do one of these types of questions. And it's a good, it sets up the rest of the chapter, gives you a good foundation. So before we start looking at area, we have to talk about summation formulas. Which involves sigma notation. You remember from Math 12, a sigma means you're summing everything in of this, what's inside. So, for example, this means I'm adding up all the terms from 1 to n of some constant c. So it'd be like constant was 2, it'd be 2 plus 2 plus 2 plus 2 n times. So in fact, the shorthand for this is just n times c. That's what will give you the answer. Second one is a famous one. The 1 to n of I will be n plus 1 over 2. And if you want, you can look up Gauss. His teacher asked him to add up all the numbers between 1 and 100. And he did it in very quickly, like less than a minute, using this formula when he was in grammar school. Number 3 is the sum. That's a bad sum sign. I is equal to 1 squared is n plus 1, 2n plus 1 over 6. And the final one that we will use, sum of I cubed 1 to n is n squared n plus 1 all squared over 4. And if you're looking for proofs of these, they're in Appendix A. And that will take you to a video, an online video that will show you how to get all those formulas. All right, so let's do one example of this. Okay, so here's my example. Evaluate from I is equal to 1 to n of I plus 1 over n squared for n equal to 10 and 100. Now, if it was 10, you could literally just plug in 10 there, and then you start 1, 2, 3, 5, and just keep going all the way. But we're going to find a general answer, and we can plug in anything we want. So, first thing is n is a constant because it's one of these numbers. You can pull constants out of a sigma notation. I don't know what's wrong with my sigmas today. Let's see again. I is equal to 1 to n of I plus 1. Now, you want to break up this, okay? Because we have a formula for I, and 1 is a constant, we have a formula for that. So we need to rewrite it as sum of I is equal to 1 to n of I plus the sum I is equal to 1 to n of 1. And the reason we did this is because we have a formula for that. So that becomes n plus 1 over 2. This is a 2, by the way, sorry. Plus, remember, it's the constant times whatever n is. So in this case, it's just n times 1. This gets multiplied in, and I have n plus 1 over 2n squared plus n over n squared. That goes away, that goes away. n plus 1 over 2n plus gone, 1 over n. If you make a common denominator, put a 2 there, 2 there. So I get n plus 3 over 2n. That will allow me to solve this for any n. So since I said n is equal to 100, or 10 or 100, so when n is equal to 10, you just put in 10. I'll get 10 plus 3 over 2 times 2 times 10, 13 over 20. When n is equal to 100, it's going to be 100 plus 3, 2 times 100, so 103 over 200. There you go. If it was 10,000, you could put that in. So what's the point of learning all this? Well, how does this bit? Okay, so we're going to start looking at curves here. I'm going to do this on this clean page here. So, estimating area. So we have a curve like that. We call this A, call this point B. I want to estimate this curve. What I can do, I can draw rectangles. If I add up the areas of the rectangles, I'm going to get an approximate area of the curve. However, this would be an underestimate because of this. You can do the same curve. Well, it's supposed to be the same curve by doing an overestimate. Okay, you can see we have an overestimate because we're including all this stuff out here, and this would be an underestimate. So this is an overestimation. All right, so how do you do that? Well, the area under this curve, blue, is going to be the sum of the rectangles, of the area of the rectangles. Just intuitively, you can look at that if I add up, because this, remember, sigma means sum. Add up the areas of all the rectangles. Okay, well, what's the formula for area of a rectangle? Well, area of a rectangle is 8 times width. Okay, width of each rectangle we're going to call delta x. And the height is going to be f of some number, because that number will change depending on where you are. Okay. Okay. So we're going to say it's the sum of I is equal to 1 to n. By the way, I is the rectangle number. This is I is equal to 1, I is equal to 2, equal to 3, etc. The height is going to be dependent on some number c. So it's going to be f of c times the width, which is delta x. Okay. Now this is the formula, but what is c and how do you find delta x? So let's do delta x. Delta x would be the difference between a and b divided by the number of rectangles, n. This is number of rectangles. Okay. C, which is the height, these numbers up here. Okay. C, for the one up here, because we start with this, it's going to be A plus. Now, if you go to the second rectangle, it's this number right here. Sorry, that one right there. Okay. So it's going to be the rectangle number times delta x. So if you're in rectangle 1, it's I1 times delta x. Boom, gives you that number. If you're in rectangle 2, it's 2 times delta x. So it's 2 delta x's plus your a value. Boom, boom. Okay, gets you that. If you well, you don't have to remember them, but in university they will expect you to remember them. Okay, we're going to practice this. I know this is probably a bit overwhelming, but we will practice this. If you're doing an overestimation, your C value is going to change a little bit. Because in this one up here, I know I draw it there, but this is your C value. It's where it's touching the graph. Okay, that's why it's A in triangle or rectangle 1 plus 1 delta x. There's your C. And then if you're in rectangle 2, it's 2 delta x. Boom, boom. It's this number right there. And then it's there. And it's there. And it's there. It's where it's touching the graph. Whereas in the overestimation, you can see it back here. So your C is going to be A plus I minus 1 delta x. That way, if you're in the first rectangle, so if I is equal to 1, this whole thing is C is equal to A plus 1 minus 1 delta x. 1 minus 1 is 0, so that goes away, so C is equal to A. So it's that number there. Okay? Everything else is the same. X is B minus A over N. And the area is equal to the summation. Wow, that is horrible. The summation I is equal to 1 n of f of c delta x. All right, let's practice one of these because these are kind of funky. All right, so I've got the notes. I'm going to click on them right now. Here it is right here. These are my notes. So find the upper and lower approximations of the area between y is equal to negative x squared plus 5 and x equals 0, x equals 2 using 5 rectangles. So this is a parabola, okay, upside down. Boom. We're going from 0 to 2. We have 5 rectangles, so I've drawn them in. Okay. All right. We are underestimating, so we're using these points right here for this one. It's the right end point. Our summation is 5 rectangles to base, so that's n. So we're going the summation from 1 to 5, that's n. The height, f of c, times the width, delta x. Well, delta x is b minus a, u minus 0, divided by the number of rectangles. So 2/5. That's delta x right there. Our c value is a plus I delta x. A is 0. I is just I, because we're going to sum all the rectangles, times delta x. What's delta x? It's 2/5. So this shortens to 2/5 I. That is your c value. All right? That goes in there, and delta x goes there, and you get this here. Now, this goes into your function, all right, which was negative x squared plus 5. So 2/5 I goes into negative x squared. So you get negative bracket 2/5 I all squared plus 5. That's the function times this number out here, 2/5. If you square 2/5 I, you get 4/25 I squared, and negative stays on the outside, plus 5 times 2/5. The 2/5 then gets multiplied in, okay? So now I have negative 8 over 125 I squared plus 2/5 times 5 is just 2, all right? Now this is just like the summation rules we did on the previous beginning of this lesson. So I break it up into two sums, right? And because this is a constant, it comes out on the I squared, right? Plus the sum from I 1 to 5 of 2 I squared, if you remember from the beginning, has a summation of n plus 1, 2n plus 1 over 6. So this whole thing turns into that. The 2 is just 2 times your n value. N value in this case will be 5, but I'm saving it until the end, okay? Once I'm at this point right here, I plug in what my n is. Remember, n was 5 rectangles. So I just plug in 5. Boom, 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 boom. Add them all together. I get 6.48. Okay? And because that was the underestimation, right? Because we're missing all this stuff in there. Right? So that's the lower value. 6.48. If you want to do the overestimation, this same formula, except your C value is going to be a plus I minus 1 delta x. A little trickier in the algebra, but this is your C, which goes in for your function. Delta x is still the same. You just have to put this into your function, negative x squared plus 5, which is this bit here. But if you follow all that algebra, you'll get 8.08. So if you use 5 rectangles, you get a range of what your area is. It is somewhere between 6.48 and 8.08. But that doesn't really help us. What we want is how do you get the actual area. Well, what you would do is make more rectangles. In fact, if you make an infinite number of rectangles, you actually get the answer. So that's what we're going to do right now. Oops. To find actual area, you do the limit as n goes to infinity of the summation of from 1 to n of the area of the rectangles, f of x, actually we'll call it f of c, consistent, f of c delta x. That will give you the area under the curve. And this is a type of question I'm going to ask you. Your C value, remember, it doesn't matter which one you use, but I find the right endpoint one, a plus I delta x, is easier to use, so that's the one I'm going to use. And your delta x value is b minus a over n being the number of rectangles. In this case, it will be infinity, so you'll see how that all works out. All right, so here's the example we're going to do. Find the area of y is equal to x squared bounded by x is equal to 0, x equals 2, and the x-axis. So basically, you draw is y is equal to x squared. We're bounded by x equals 0, which is right this line here, it's the y-axis, and x is equal to 2. So we are finding this area in here. Okay, so let's do this. We'll do it in black. First thing is find your delta x. That is b minus a over n. So 2 minus 0 over n, so it's just 2 over n. There's delta x. Easy. Next thing, find your c value. C, ai plus delta x. A is 0. This term. That would be a, b. 0 plus I. What's delta x? 2 over n. Right? So it's going to be 2i over n. There's your c value. All right. Next bit is put it into the formula above. So the area is going to be the limit as n goes to infinity. The summation I is equal to 1 to n. F of c. What's my c value? 2i over n times delta x. Delta x is 2 over n. So now it's just algebra. This bit goes into your function, which is x squared. So it's 2i over n all squared, 2 over n. Okay. And then we just start crunching the numbers. So 2 squared, I squared, n squared. So I'm going to get the limit as n goes to infinity of the sum I is equal to 1 to n of 4 I squared over n squared times 2 over n, which becomes 2 times 4 is 8 I squared over n cubed. All right. N is a constant, all right, because it's the number of rectangles that we're doing. And 8 is a constant, so you can pull constants out. So the limit of n goes to infinity of 8 over n cubed. Summation I is equal to 1 to n of I squared. This is good because this is one of the things in the very beginning. And I don't know if you remember, or you're looking through your notes, but the sum of I squared is n cubed of n plus 1 to n plus 1 over 6. There we go. Now this is just a limit question. Okay. Well, let's simplify it first. So let's this n cubed. So we'll cancel that n. That becomes squared. I'm going to pull that 6 out. Limit n goes to infinity of 8 over 6 n plus 1 2 n plus 1 over n squared. If you multiply up the top, I'm going to get 2n squared plus 3n plus 1 all over n squared. That n goes to each one of those. You can see these are pain in the butt. This is not how you do all of them. There is a shorter way. So I'm going to get 2 plus 3 over n plus 1 over n squared. And then so if we do the limit as n goes to infinity, that goes up to 0, that goes to 0, and I'm left with 8 over 6 times 2, which is 16 over 6, which is 8 over 3, which is about 2.67, which, when we learn how to actually do one of these, is the actual answer. Okay? So 8/3 or 2.67 is this area. Whoa, is that area? 8/3 That's the area of that graph. Right, whatever units you're using. Okay? That's a lot of work. It's a lot of algebra. The setup is the trick, and then once you've got the setup, the algebra just kind of works its way out. So this next one, I'm going to set it up for you. I've got the notes in this lesson, so I'll let you work through that, but I'll help you set it up. So find the area bounded by is equal to x squared plus 1, x is equal to 1, x is equal to 2, and the x-axis. Okay. I always do a quick sketch. You don't have to, but me, I just like it. X squared plus 1, 1. Parabola looks like that. X is equal to 1, there. X is equal to 2, is there. And the x-axis. So essentially, I could have drawn that a little better. We're finding this area in here. Okay. All right. So first step, find delta x. B minus a over n. 2 minus 1 over n. 1 over n. There's your delta x. You got to mark. C is a plus I delta x. A value is 1. I is I. Delta x is 1 over n. So it's 1 plus I over n. That is your C value. The formula is the limit as n goes to infinity of the summation from 1 to n of f of c delta x, which is limit as n goes to infinity, summation I from 1 to n f of your c value 1 plus I over n delta x. Remember, this bit subs into y is equal to x squared plus 1. So this is the last step I'm going to show you, and then you're on your own. You're going to get the limit as n goes to infinity, the summation I equal to 1 to n. That goes into there, so you get 1 plus I n squared plus 1. That's the function times your delta x, and your delta x was 1 over n. Okay? You're going to have to square that. Okay? Multiply it out, 1 plus I over n times 1 plus I over n. and then expand and simplify. Okay, and take it all the way through. It's just going to be algebra. The answer, I'll give you a second here. I pull this up. I scroll down. And there is your answer. I'll leave it there for a sec, so you can pause the video. Once you get to this point here, you can solve it over here, or you can simplify it a little more through this stuff, but you end up with the same answer. Okay. Don't worry about this. We haven't learned that yet. We'll learn that. So there's your answer. It should be 3.3 or 10, 3.3 repeating, or 10 over 3. If you get that, that's awesome. Here's a couple of questions that you should practice if you want to practice. Remember, I will ask you one question like this. Page 264, number 45 and 47. Please email me if you have any questions. I know this stuff is tricky, but it'll give you a good understanding of where we're going in the next little bit. There is a shorter way to do this. This is sort of the equivalent of the limit definition of a derivative. This is the limit definition of an integration, essentially. All right. Let me know if you have any questions. Good luck, people. Whoops.